Hello dear students, welcome to a new video. In this video I'm going to explain for you quadratic functions, which is lesson 1 in chapter 3 in our book. So students, I'm going to start with the basic or with the definition of quadratic expressions. What's different, function or expression or equation? Actually the same thing, since we are saying quadratic. Of course the expression different than function, I mean the quadratic, okay? So students, the standard form, or how we can express the quadratic expression or function anyway, we should say ax squared plus bx plus c. This is the general form or standard form of quadratic expression, such that a should not be 0. Students, note that a should not be 0 because the simple definition of quadratic means the greatest power of x should be 2. Even though we have x power 1, we have no problem, but the most important thing is what we should have x squared. If the greatest power in our expression or in our function, a function means f of x equals x squared ax squared plus bx plus c, right? If you have this form of your function, then it means this is quadratic. Okay, students, let's take a look at this. This is a graph, by the way. This is a U-shape. Usually U-shape means the quadratic, okay? I'm going to explain more about the graph later at the end of this video. We have some important notes, students. In the following cases, the function or the expression is not quadratic. If you have x squared or x in denominator, if you have x squared or x in denominator, suppose 1 over x squared if you have, then this is not quadratic. If you have x or x squared inside absolute value, like something like this, or even x inside absolute value, this is not quadratic, okay? Or if you have exponential, like x squared or x in a power, like this, for example, e to the power of x squared, or let's say 3 to the power x. These things, this is not quadratic. When x squared or x under square root, like this one, x squared plus 1, something like this. Or when the greatest power is not 2, let's say if you have x power 3 plus x squared plus 1, this is not quadratic, right? Very simple. So let's take some examples to understand better the topic, which these examples say identify the function whether it's quadratic or not. First one, students, we say in which cases are not quadratic. Inside absolute value, remember. In denominator, when x or x squared, inside absolute value in denominator, or inside square root, or in the power, then if x in these cases are not quadratic. First one, is that any of the cases that below I explained? No. So it means x squared, this is quadratic. Second one, f of x equals x squared plus 1 over x plus 5. Note that I have x in denominator, 1 over x. So in this case, this is not quadratic. Third one, I have 3 minus x squared plus 4. Students, note that I have x squared, greatest power, and I have x, I have no problem. But if you see this x squared, there's multiplication. When you multiply inside the bracket, you get 3 minus x times x squared going to be x power 3, then x times the other one going to be minus 4x. Right now the greatest power is not 2, is actually 3. So this is also not quadratic. Last one, not last one, I mean fourth one, f of x equals 8 minus x. Students, here 8 minus x, x is power 1. We say the greatest power must be power 2, but here actually is power 1. So also this is not quadratic. Let's go to the fifth one. F of x equals x squared plus 4, but we have something else, which is x squared plus 4 is inside absolute value. When is inside absolute value, students, directly is not quadratic. All right, last one but not least, f of x equals x squared plus 1 over 2x plus 5. As you can see here, x squared or x is not in denominator on the square root or inside absolute value, so this is quadratic without any problem. Students, something else that we should study in this section, which is how to show or how to prove a function is quadratic. For example, I have f of x equals x plus 1, x minus 7 is quadratic. When the question says show that, it means 100% this is quadratic, but you need to prove it. Okay, this page 110 in our book is quadratic. Identify the value of a, b, and c. Remember the standard form f of x was ax squared plus bx plus c. Then we need to write x plus 1, x minus 7 in this form, then identify the value of a, b, and c. Okay, students, let's start. Let's rewrite. F of x equals x plus 1, then x minus 7, right? X plus 1, x minus 7. Students, just change the color, like I'm using red today a lot. Okay, no worries. In order to to expand these two brackets, we need to start with the first bracket and first term, which is x. Multiply x by x and by 7. Okay, then we obtain x times x equals x squared. Then x times negative 7, be careful, equals negative 7x. Then x finished. We will go to the second term in the bracket, which is 1, right? Positive 1. Positive 1 times x equals positive 1x. Then positive 1 times negative 7 again, going to be negative 7. Now let's simplify, students. In order to simplify this one, we need to combine like terms. Then f of x equals x squared. There's no like terms to simplify with x squared, so going to be the same, x squared. But negative 7 and positive 1, they have both x power 1, so they are like terms. So negative 7 positive 1, 1 negative 1 positive, we are going to subtract by using the sign of larger number. So when you subtract 7 minus 1, going to be 6, but with a negative sign, because 7 is greater and is negative. Then the other one is negative 7. So the final step to do is what? To identify the values of a, b, and c. The one with x squared going to be a. How much we have with x squared is 1. So a equal 1, b equal the one with x going to be b, so negative 6 with a negative, please. And the third one going to be c, the number, the constant, which is negative 7. So then something else about the section, which minimum and maximum value that you need to know about quadratic functions or expressions. Students, look, if x squared was positive, then the parabola is the U shape, is a graph of quadratic. It opens upward, okay, and it has minimum value. So when x squared is positive, the graph going to be U shape upward, okay, when it's positive. And this value, students, as you can see here, let me change the color. This value here, this is the vertex or the head. The vertex. This vertex is very important because this is the head of the parabola. This is calling parabola. This is parabola. Parabola. Okay, this U shape. This vertex is very important. This vertex is minimum value or maximum value. When, as you can see, comparing with these vertex on the graph, this one the least one or the smallest one, right? So this is mean value, all right? But when x squared is negative, so when it's negative, so the graph going to be opens downward like this. The U going to be reflecting, and this is the head of the U shape. And this head, students, this is going to be max value. All right, this is going to be max value. Well, let's take some examples. The question says the following quadratic functions are opens upward or opens downward. The vertex has max or minimum value. Okay, students, first one, as you can see, the x squared is positive, so we can say this is opens upward. All right, and it has maximum minimum, so remember the U shape, this point is mean value. It has mean value. How about this one? As you can see, x squared is negative. Just you will check x squared is negative, so this is opens downward, and it has max value. The vertex, the graph is like this vertex. Okay, it has max value. Okay, next we have C, 5 minus x squared plus x. Students, just check x squared. This is not negative, yes, so it is again opens downward, and it has max value, the vertex. And the other one, y equals 7x plus x squared, again x squared is positive, opens upward, it has main value. Okay, students, something else about transformation, about quadratic, which transformation. Transformation, we have horizontally transformation and vertical transformation. Also, we have reflection. Students, when the quadratic going to be vertically transformation, look, if you have y equals x squared by itself plus or minus a number, which is, let's say a can be any number. When it's positive, this u shape goes up, transforming up. When it's negative, this is going to be down. Okay, will go down. How about horizontally? Because vertically means on the y-axis, horizontally on the x-axis. When y equals x plus or minus a number square. Students, when this one positive, you'll go opposite direction. It goes left. How about negative? It goes right. Okay, in which case going to be reflection? When we have y equals negative in front of let's say x plus or minus a squared, or y equals negative x squared plus or minus a. When you have negative in front of your bracket, then going to be reflection. Right now we will take some examples. Okay, students, let's check the questions saying describe how do you transform the parent quadratic function to each of the following functions. About 37, I have y equal x minus 2 squared then minus 1. The parent quadratic function, students, let me graph it here for you. I'm sorry. Okay, let me graph it here for you. Look, the parent was in the origin point was u-shape here. This is the graph of f of x equals x power 2. Then when you have x minus 2 squared minus 1, remember I explained it here, it is horizontally, vertically, of course horizontally. So this negative 2 will take the quadratic function 2 units to right, because opposite sign. And how about this negative 1? Because it's outside, will take down, right? Will take down. So we can say 2 right and 1 down. Okay, so the graph, if I graph for you, the question say 2 right, this is 1, 2 right and 1 down. So this is the head of the vertex, but since in front of we have positive, so we'll go upward. Understood? 39. About question 39, students, I have negative in front of the bracket. Be careful. So this negative inside again will take us to right. True. And how about this positive will take us to up? So going to be 2 right, 2 squares right and 1 square up. And if we graph, the graph going to be 2 right, 1, 2, and 1 up. So this is 2, this is 1, this is the head of parabola. But since our parabola there's a negative in front of, so going to be downward. We are learning this one, right? This is going to be the graph. Last one but not least for today, I have negative inside, so this is negative. Again, we'll take 3 to the right. In case, well, let's change the question. Let's make this one positive. Okay, because you had two negative. So x plus 3, so we can say this is to the left. And how about this one? 2 down. Outside same sign, but inside the bracket opposite sign. So we can say 3 left and 2 down. Okay, let's graph. Let's see. We say that, students, 2, 3 left, 1, 2, 3 left, and 2 down, 1, 2. So this is going to be the head of the parabola, but since we have negative, so going to be opens down. That's all for this video. Thank you for watching, and stay tuned for upcoming videos. Bye.